Okay, let me talk about something kind of important in calculus, and that's the theory of the derivative. And it's just one of the more important things you learn in calculus. And in algebra, you learn that the slope was rise over run, or delta y over delta x, or whatever. And that's fine if you have a linear function that's just a line, or if you want to say take the average rate of change of a function. But what about if we want to know the slope at a point, say x0? So that's the whole purpose of the derivative. And so the theory behind that is basically we start out we start off trying to approximate the slope at x0 by taking the slope of a secant line between x0 and another point, and that's this red line. And as you can see, that's not a really good approximation. It's kind of crappy, and so we try to move our point a little bit closer, and that's, to be honest, that's an even worse approximation because this one is positive, this one is negative. But notice that as we move our second point closer and closer to x0, we get a much better approximation for the slope at that point. And this black line here is a much better approximation than these other two lines, the red line and the blue line. And so the theory is that as we make delta x go to 0. In other words, as we bring this point closer to this point, we bring the 2 points so close that they're basically on top of each other. And at that point, we have the derivative, basically. Um, you can write as f prime of x or dy dx, whichever. But that's basically the instantaneous rate of change of the function, or the instantaneous slope at that point. I mean, obviously the slope changes in this kind of curvy function we have here, but at that point at x0, the slope is given by dy dx. So you can think of the derivative of a function as basically being the slope at that point, and this is how it works by shrinking delta x to 0. And don't worry about this limit notation. I'll explain that some other time. But it basically makes delta x really small. And if delta x is really small, then delta y is really small. And if it goes to 0, then we have just one line, and that is the derivative. So hopefully that explains what the derivative is more or less conceptually.